in this video we are going to be focusing a little bit on amides. So let's first of all start off with what I mean by an amide. So the general structure of an amide starts off very similar to a carboxylic acid. So it is a derivative of carboxylic acid, so that means it can be hydrolyzed back down to that parent carboxylic acid. So now over here, instead of that hydroxyl group, we actually have a nitrogen group here. Okay, and obviously nitrogen needs to have 3 bonds, so it can be bonded to other R groups. Those R groups can be hydrogens, depending on what that molecule is. Okay, so this is what we mean by an amide. You must have a nitrogen group directly bonded to that carbonyl group there. Okay, so just to kind of make it a bit clearer, so this part here is the amide group. Okay, if you do have a compound that looks like this, like that, this over here is not an amide. Okay, this is not an amide because that nitrogen isn't directly bonded to that carbonyl there. Okay, this is literally just an amine group, and you've got a ketone over here. This is not an amide, so just be careful of the difference between a ketone and an amide, an amine, and what we mean by an amide bond. Okay. Right, so first things first, let's now classify our amides. So you can have different types of amides. So again, remember when we're classifying, we are essentially putting under primary, secondary and tertiary. So let's have a look at a primary amide. So a primary amide is one where the nitrogen here in that amide is bonded to 2 hydrogens, like that. Okay, so there are no kind of carbon chains coming off of that nitrogen there. So that's a primary amide where the nitrogen is bonded to 2 hydrogens. A secondary amide is therefore one where the nitrogen is only bonded to 1 hydrogen and an R group. Okay, so there's 1 hydrogen attached to this one, the other one is an R group, and therefore a tertiary amide is one where there are no hydrogens attached to the nitrogen and there are just R groups attached to that. Okay, the R groups can be whatever, we don't really mind about that at the moment, but it's how many hydrogens are bonded to the nitrogen. This one there are 2 hydrogens, this one there is 1, this one there are none, and that's how you classify amides. Let's just quickly kind of cover how we name these types of amides. I'm just going to quickly cover a primary amide. So a primary amide like this one. Okay, primary because it's 2 hydrogens attached to the nitrogen. All we do is we look at the longest carbon chain. In this case, it's 2. So it's going to start off with ethan. And all we do is, because we've got amide over here, it is amide at the end here. So that this compound here is called ethanamide. So if we just extend the carbon chain, so for example, like that, so the longest carbon chain is now 3, so this one over here would be called propanamide, like that. Okay, just do one more example as a skeletal form. Like that. So again, just double check you've got an amide. So nitrogen is directly bonded to your carbonyl group, so that is an amide bond. So 1, 2, 3, 4, 5. So longest carbon chain is 5, and therefore this one here is called pentanamide, like so. Okay, let's quickly cover a secondary one. Like that. Okay, we have a methyl group coming off over here, hydrogen coming off there, and we have, so double check you've got an amide there. Okay, so for this one we just go with what name we would have done it without that there. So longest carbon chain is 2, so technically that part there is called ethanamide, so that means this is going to end in ethanamide. Okay, and now we've got a methyl branch coming off of the nitrogen, so therefore this is just called N-methyl ethanamide, like that. And if we now have a tertiary amide, I'm just going to stick with the same groups, similar to that. So now we have a tertiary amide, again, longest carbon chain, that's related to, that's next to the carbonyl. Again, I've just gone for ethanamide, so it's going to end in ethanamide. But now we've got 2 groups coming off the nitrogen. We've got an ethyl and we've got a methyl. They will go alphabetically, so therefore the name is N-ethyl, N-methyl ethanamide, like that. Okay, so it is similar to how we name amines in terms of the branches. Right, let's now cover how we make an amide. So the synthesis of amides. Now, amides are made through using acyl chlorides. Okay, so let's just recap. We've got an acyl chloride like this, so that's an acyl chloride. Now, to make a primary amide, all we do is react this acyl chloride with ammonia. Okay, so this is going to give rise to a primary amide, and the primary amide is this one here. I've just left an R to keep it generic. So that's the primary amide it would make. There are going to be other products, so as you can see, we are going to release a H+, we're going to release a Cl. We actually form a salt as the other product, and the salt that we form is NH4Cl, so that's ammonium chloride in this case. Okay, and in order to balance it, we just need to have 2 lots of ammonia like that. Okay, so that chloride, 1 ammonia molecule and 1 hydrogen that we've lost from that ammonia end up in here. Okay, so this is how we make a primary amide. We react together an acyl chloride plus ammonia, and we form our primary amide, and we form this ammonium salt. Okay, ammonium chloride in this case. Right. Let's now have a look at how we might make a secondary amide. So secondary amide is just the same. So we still use a acyl chloride. But now, rather than reacting it with ammonia, we react it with an amine. Okay, so if I choose this primary amine, so that is just methylamine. So if I just react this with methylamine, we are going to form this amide over here, and we are going to form our salt as well. So in this case, the salt that we form is CH3NH, like that. And again, just to balance it, we do that. Okay, so now to make a secondary amide, we react together an acyl chloride with a primary amine. That gives rise to a secondary amide, and our ammonium salt. Okay, so just by extension, if I want to make a tertiary amide, I would use a secondary amine, and that's going to give rise to my tertiary amide.